An airport built in the middle of the sea, and it's sinking. How was that even possible? Stay tuned to discover the secrets behind Kansai International Airport. Welcome to Kansai International Airport in Japan, a masterpiece of engineering that celebrates 30 years of operation. This airport was the first in the world to be built on an artificial island in the ocean and holds the record for having the longest terminal on the planet. Moreover, it impresses with its incredible efficiency. It has an almost zero rate of lost baggage. However, not everything is a victory. Behind this success lies a massive challenge. The airport is literally sinking. Yet despite this, a multi-billion-dollar renovation is underway to expand its capacity and ensure its importance as a regional hub. But how was it even possible to build an airport in the middle of the sea? Where did things get out of control? And what does the future hold for this giant that constantly battles the challenge of subsidence? Since its conception, Kansai International Airport has faced one of the greatest geological challenges for a project of this scale: unstable soil. The artificial island on which it was built began sinking shortly after its construction. Although engineers expected some degree of soil compression, the initial forecasts underestimated the problem. The rate of sinking was much faster and more intense than anticipated, raising serious concerns about the structure's stability and the safety of its operations. This phenomenon, known as subsidence, occurs because the underlying soil layers cannot support the massive weight of the infrastructure. Since its inauguration, the airport has sunk about 13 meters, requiring constant monitoring and periodic interventions to ensure the functionality and safety of operations. Subsidence directly impacts various areas of the airport. The runways, taxiways, terminals, and drainage systems need to be frequently leveled to maintain a stable and safe surface for aircraft operations. Without rigorous monitoring and constant corrections, operations could be seriously compromised. Furthermore, the cost of these adaptations was not fully accounted for in the initial budget, making maintenance an increasingly expensive burden. To mitigate the problem, several solutions have been implemented over the years. One of the first attempts was the installation of deep piles, seeking support in more stable seabed layers. As the sinking continued, more advanced strategies were adopted, such as constant recalibration of runway height and the installation of real-time monitoring sensors. These sensors provide accurate data on soil compaction and island movement, allowing engineers to make quick decisions to prevent more severe damage. Drones are frequently used to inspect hard-to-reach areas, while artificial intelligence, AI, helps predict when and where the soil will sink further. This allows for preventive measures and avoids interruptions in operations. This combination of advanced technology and long-term planning is an inspiring example of how innovation can turn a major challenge into an opportunity for constant evolution. The economic impact of Kansai International Airport is also significant. More than just a transportation infrastructure, it is a crucial economic engine for the Osaka region and Japan as a whole. Since its inauguration, Kansai has become an important logistics hub in Asia, facilitating the movement of goods and passengers between Japan and the rest of the world. The airport has driven regional economic growth, attracting investments and creating thousands of jobs in tourism, commerce, hospitality, and logistics sectors. It is estimated that the airport handles millions of tons of cargo annually, playing a key role in the export of high-tech products and automotive components. In recent years, Kansai has undergone a series of upgrades to modernize its facilities and prepare for the future. In 2019, a $500 million project was launched to increase passenger capacity, modernize the terminals, and adopt technologies to make the airport more resilient to climate change. These improvements have not only raised the airport's efficiency standards, but also made it more competitive compared to other major Asian hubs such as Narita, Incheon, and Changi. Continuous modernization is essential for Kansai to maintain its prominent position on the international stage. In addition to structural upgrades, sustainability has also become a key focus in the airport's future planning. Kansai is adopting sustainable practices to reduce its carbon footprint, such as using solar energy and systems for capturing and reusing water. LED lighting and efficient climate control systems help reduce energy consumption, making operations greener. However, sustainability is not limited to the use of natural resources. Emerging technologies such as artificial intelligence and automation are also being integrated into the airport systems to improve operational efficiency. Nature also challenges Kansai relentlessly. In 2018, Typhoon Jebi hit Japan with devastating force, causing significant damage to the airport. The runways were submerged, operations were halted, and a ship collided with a bridge connecting the island to the mainland, temporarily isolating the airport. This episode highlighted the airport's vulnerability to natural disasters such as typhoons, tsunamis, and rising sea levels. Since then, Kansai has reinforced its flood defenses, built higher barriers, and improved its drainage systems, preparing for future extreme weather events. Kansai International Airport is not only an example of innovation and resilience but also a portrait of the challenges modern engineering faces. The future looks promising, especially with the advancement of real-time monitoring technologies, artificial intelligence, and automation. These resources make Kansai a model for airports around the world that face similar challenges. While the ground beneath the airport continues to sink slowly, Kansai keeps adapting and evolving, proving that even the biggest obstacles can be overcome with technology, planning, and a forward-thinking vision.